All right, hi there. My name is Erik, and I'm coming to you from the voiceover for the first 5 minutes of this talk. Because unfortunately, I missed to activate the microphone and camera for the first 5 minutes. I will still tell you everything that I talked about during the meetup, and after the 5 minute mark, you will be back with the original audio and video. So let's get going. So this talk is about predictive preloads, and we will go into some details on what is actually preloading and how does preloading and pre-rendering work in the browser. But we will also look into how predictive or what is predictive actually about this solution of predictive preloading. And we will be looking into how this can bring us closer to the dream about an instant web that we all have. But I think most importantly, we will not stop at the theory and a few tests about predictive preload. We will actually look into some real world data of that and A/B test results on 100 million users. And this is actually where the cool logos at the bottom come into play, because with SpeakIt we are fortunate enough to work with really large companies in order to improve their performance with our tool, but we've also deployed real user monitoring for all of those pages. And this gives us the opportunity to actually do A/B tests on new performance features with those customers together, and then we are actually able to test new features across more than 100 million users in order to make sure that things that we are developing actually work in production as well. But before we come to that, let's start at the beginning and talk about what is actually predictive preloading. And let's actually start with what is preloading in the first place. So actually we have a lot of cool tools in the browser available to do preloading. So to get resources or data that the user needs later on during visiting the page. And to start at the very top, the first thing that we see is we have different link tags in order to instruct the browser to perform an action in order to prepare for kind of next things that the user needs. And the first thing that we start with here is a DNS prefetch. So you have a link tag with a rel attribute that says DNS prefetch, and you give it an href. And what this does is it resolves the DNS to a given domain. So whenever you need a connection to a domain later on in your code, but it's not directly visible to the preload scanner, you might want to already prefetch the DNS for that entry if the resource is really critical for you. Even better, today what you would use is the next thing here, which is the pre-connect link tag. And this not only resolves the DNS to the domain, but it also sets up a complete TLS connection. I think the only reason that you would use DNS prefetch over pre-connect, if you're actually sure that you need the connection soon for a critical resource, is that I think DNS prefetch works in a few more browser versions, but usually you are good if you use pre-connect. So currently we haven't preloaded any resources or anything like that yet. We've only looked into setting up a connection. The next one up here is actually a link tag that does preload resources for later use. It always preloads things for later use on the same page. So you should be sure that the resource is used on the page that you're currently loading. But with that, you can, for example, give it a link to a critical JavaScript file. Again, a file that is not directly visible to the preload scanner in your HTML. In those cases, you might want to add a preload tag for that. So up until now, we've only talked about resources that are used on the current page that the user is currently on. Let's go one step further and talk about a new link tag that actually lets us preload or prefetch resources that are meant for a different page or for a page down the line. And this link tag is called prefetch. And this time you can even give it a document. You can give it the path to an HTML file of yours. You can also use this for resources, but it's often used for HTMLs. And now we are actually into the realms of actually prefetching pages for the user to later navigate to. So what this will do, it will download the whole document and will store it in the prefetch cache, so that when the user actually clicks on a link to that page, the HTML can be retrieved from the cache. What it will not do at this point is pre-render or prefetch any of the linked resources in order to have resources ready to render the page. It will only prefetch the document for later use.
Yes.
All right, and this is the point in time where the audio kicks in again. So please enjoy the rest of the talk, and yeah, feel free to leave any comments of things that you might want to ask.
So now with sound. After prefetch, the kind of next thing that it does even more will be, and now I have to click on this one again, will be pre-render. And that sounds like it will pre-render the page, and that was actually supposed to, so it was supposed to do that. It doesn't do that anymore, and kind of that functionality is a bit deprecated now. But what Chrome will do instead is what is called no-state prefetch. And that goes one step above prefetching. It will actually download the HTML, and it will also download, or it will spin up a preload scanner for that HTML, and it will download all the resources that are linked on that directly. So that kind of the browser, when the user actually clicks on the link, has almost everything ready in order to render the page, at least if that is already defined in the markup. So that is almost as good as it gets, but we can go one step further, and this is actually quite new. So I think the blog post from Barry Pollard is from December 2022. And the next best thing is actually speculation rules. And with speculation rules, you are actually able to do pre-render as in pre-render and not as in no-state prefetch. So that's pretty awesome. So the syntax is a little bit different. It's not a link tag, it's a script tag that has type speculation rules. Then you have a structure inside where you essentially list all the URLs that you want to pre-render. In this case, we only have the article here. And what this will do, it essentially kind of spins up a background tab, if you will. It will download the resources. It will actually render the page in the background. So do DOM, CSS, render tree, do the actual layouting and everything. And it will even execute your full JavaScript. So it will kind of load the page in the background, but not show it yet. And that is kind of the best thing in web performance that you can get, because when the user now clicks on the link, you will just kind of switch it into view. So the browser doesn't have to do anything anymore. Of course, that also has some caveats. If it executes all the JavaScript, your tracking will probably think that the user visited the page. That is a bit strange, and you have to deal with that. There are events to hook into and such that you can detect that. But this is essentially what happens. And this will get you pretty far, and we will see an example of that very shortly. Now, this all obviously comes at some cost and with some benefit. And this is not a linear scale, I would say, but it's definitely true that the cost and also the benefit increases from the top to the bottom. So you can do a lot of DNS prefetches without shooting you in the foot, but you can't do too many pre-renders in the background, especially on mobile devices, if your performance and the user's device should still stay intact. So you definitely have to be really cautious and be really good about the predictions that you do in order to pull something off like pre-rendering. And that leads us to the prediction part. So we talked about predictive preloads. We already covered what preloading is. Predictive about this part is, of course, doing an estimation where the user will navigate next. So given a category page, for example, given information about the user, given information about how does the user interact with the page, what links are visible, how does he scroll, where's the mouse, where's the finger, no, maybe not where's the finger, you can't really, it's hard to detect. But you can define some kind of model, compute some probabilities, where will the user click next, and then potentially preload exactly that. And if you combine these two together, you can actually get astonishing things done, I think. For the speculation rules and pre-rendering part, I actually brought an example here of our corporate website. So really kind of basic website, pretty fast anyways. Tested on web page test. The top row is without pre-rendering. The bottom row is with pre-rendering. The connection speed is quite low. But what you can see, for example, is so at the top, the rendering only starts after 0.4 seconds. So this is essentially the time to first byte the browser took to actually download the HTML. And then 100 milliseconds later, so at half a second, you see there is some text rendered and kind of the first icons. And then it takes another 1.5 seconds for essentially the images and everything to load so that you have your largest contentful paint. And with the same connection speed, we actually took the time while the user was browsing the landing page in order to pre-render the next page. And with pre-rendering, you just get an instant experience. So the user clicks and not just 100 milliseconds later, you have your largest contentful paint and the page is completely there. So pretty exciting, I would think. And we are getting really close to kind of the instant page load performance that we are essentially all craving. So big question, if that is so impressive and you can get to so great performance, why is not everybody doing that? Why is not at least every online shop which conversions depend on speed, why is not everyone doing this already? Why haven't we heard about that? And in order to answer that, let's look at what is actually needed in order to implement something like that. So of course we need something where we track user data. So probably we need user data in order to do good predictions. Maybe we can do also a lot of on-page stuff, but at some points I think we definitely need user data. Then we need to define and train a model that can be combined of doing things on the client, on the server, crunching some data, machine learning, ChatGPT, maybe not. Yeah, but then in the end, we need to deliver something to the client, and the client needs to do the pre-rendering, the preloading. And while the left two things may be hard, and yeah, to perfect them is, I think, extraordinarily hard. But you can start simple, and you can do something, and you can do some tests, and probably get quite nice results already with kind of really simple approaches. What I think is extremely hard if you have a large online shop with a lot of users and complex systems is, to be honest, the preloading part. And not the client part of it. We've talked about that. There are a lot of ways you can do preloading. But actually the infrastructure and server and logic part behind it. Because imagine you do this pre-rendering and you pre-render on every page load the kind of top 3 pages with the biggest probability. You just quadruple your traffic. And if you have a WordPress blog, that may be okay, but if you are Amazon, you get in trouble for that and you pay a lot of money. Well, in Amazon's case, maybe to themselves for AWS, but you get the point, I guess. So server load is a huge problem and you can't really circumvent that if you want to do more than once in a while the preload. Second thing is pages are personalized. If you preload something and then the user does something that changes the session state, like adding something to the cart, and you then show a pre-rendered page when the user clicks on it, the cart icon is wrong. And users don't like that. They like performance, but they also don't like broken pages. And then again, a lot of shop systems, page loads actually are not side effect free. So they change stuff. If you click on something, a product, for example, then this is your last seen product, and it will kind of have an effect on your further experience. If something is preloaded and it looks like the user went there, yeah, that changes the state, and so all of a sudden users visited pages they never visited. So you have to accommodate for that. And also the JavaScript thing, when you talk about pre-rendering, we talked about that. So I think you can implement stuff to cope with that. The server load problem is I think the hardest. And the only way around this, and the only way to solve this, we see, is actually you need something like HTML caching. If you don't cache your HTML, you probably shouldn't preload too many things, because your server load will explode and you have a lot of costs, but also a lot of engineering problems in order to cope with so many requests. With HTML caching, you don't. You can just let this handle by CDN, for example. And this is actually where it gets super interesting for us as a company, this use case, because what we do in order to push the performance with our customers is do HTML caching with them, and without actually changing their stack. And I have to quickly jump into how that works so you understand how this enables us to actually preload in the first place. So let's do this super quick. With SpeedKit, what we do is we automate HTML caching, or caching in general for the customer. And we don't do this as a classical CDN, which you integrate into your infrastructure. In fact, the infrastructure stays completely as it is. We come in through JavaScript, as strange as that may sound. And we are using service workers to do that. So service worker in the background thread of a browser intercepts all the requests going to the network and can reroute stuff to a different endpoint. In this case, caching endpoint, distributed cache network of ours, even caching in the client and everything. And we're not only doing this for kind of standard cacheable things like JavaScript, CSS, but we're doing this for HTML. And this in shop systems where HTML is personalized. So that means we make sure that personalization still comes from the origin server, because our servers don't do that. And also kind of blacklisted content as well. And of course, we need to keep everything in sync, because we're after all caching things that can change at any point in time. Don't want to speak about how we are doing the caching exactly, or how we keep everything in sync, even though that is super interesting. Want to talk about a bit about how does that personalization thing work, because that is the one that will then enable the HTML caching in the first place. So with personalization, how do we actually do that? Imagine we are navigating onto a shop page, let's say product page, for example. The first thing that the browser needs to do is do the HTML request to the browser, to the server. And with SpeedKit, this changes a little bit. So with SpeedKit, we will do actually 2 requests in parallel, not one HTML, but 2. And one request will go to our infrastructure. It will load an anonymous version of the page. So no user logged in, nothing in the shopping cart, just kind of what the Googlebot would see if visiting the page. The second request, all cookies attached, user logged in, something in the shopping cart, recommendations, will go to the backend server and just retrieve the normal HTML as any other user without SpeedKit would. And then usually the cached version is much, much faster already, so that is pretty cool. And the browser can already deal with that. It can load all the dependencies, have the DOM, the CSS ready, the render tree, and actually paint the anonymous version of the page. And then once the original version from the origin server arrives, we are actually merging these 2 HTMLs together. So also the other content appears. And this way we can actually separate the things that need to come from the origin server at all times and the things that can come out of a cache node. In this way, we are able to preload the upper one, so the cached one, and only request the personalized one on demand when the user actually clicks. This way, we are enabling even trying that technology for large e-commerce customers that kind of can't do the HTML caching on that level as efficiently otherwise. Right. So this leaves us with the right side sorted, sort of. And also, I don't want to touch too much on the left side. So we have real user monitoring stack build that is complex, but you can do it, and there are solutions out there. And I want to focus today on the model part. So if we have data and we know how to preload, how do we decide what to preload, and what are kind of the first steps into the direction? So let's do a bit of data science here. Before we actually start with the first model, we have to think about what is actually our success measure. So when are we happy with the result? Now, of course, we want to improve user experience, right? So what we would need to do is actually improve largest contentful paint, for example, or CLS. And the only way to really measure that is doing a A/B test in production with a bunch of users, measure this with the real user monitoring tool, and then evaluate, okay, 50% had preloads, the other 50% not, and then see what did actually happen. And we need to do this in the end, because if that is not satisfied, then why did we do it? But to train and to compare and to tune models, that would be quite cumbersome. So for every parameter that we tweak during an A/B test in production, yeah, no, please not. So what we do instead, kind of on the first level, we go to kind of standard data science, and we calculate for our prediction system the recall and the precision. So how many, or let's say, how many of the navigations that a user did in a data set did we actually preload with our system? And the precision part from the ones that were actually used, the preloads, what is the relation to all the preloads that we've done? And then we can even compute something like F1 score in order to combine these two metrics into one formula to compare everything to each other. Another thing before we actually get into the first model, what we need is a baseline. So we always need to compare against something. Otherwise, we don't know, is it a good system or a bad system? And the way that we can do this is we preload based on hover. So super, super simple idea. Just when the user hovers with the mouse over a link, we preload the link. When the user touches down on a mobile device on the link, we preload the link. So let's just try that as kind of a default approach and see how good it is. That's actually super easy to do. We can just track some data, look at the data. This is one day from one of our customers, 150,000 sessions. 109,000 of those would have been preloaded with this hover preloading. That is impressive. And we did 1.8 million preloads in order to do so. That is less impressive. So we can calculate the recall at 71%. We can calculate the precision at 5.8 and the F1 score at 10.7. So let's accept that as a baseline. Of course, it comes with a lot of limitations. Like when you hover, it's probably a bit too late to preload. At least for pre-render, you need some time before the user actually clicks. And also the precision is not that good. And also it ignores kind of JavaScript navigations if you do that a lot. But that's our baseline. And now let's go to the first approach. And before we actually go anywhere near machine learning, I would urge everyone who has kind of a similar problem to always try and think, is there maybe a mathematical approach before we try kind of deep learning and asking ChatGPT about it? And I think if you've seen this in university or in school even, Markov chains, they really scream to be used here because we have kind of a system that has navigations or transitions between states. This is essentially what Markov chains are about. So just to remind you, we have kind of a system of states, in this case, the weather, sunny, cloudy, rainy, and we have transitions between them. And all of these transitions kind of boil down to probabilities between those states. And the Markov approach here is that every transition only depends on the state before it. So that it's cloudy, the third day only depends on the second day that it's sunny, not on the day before that. And that makes things easier. It's not necessarily true for every problem, but it's an assumption that simplifies things. There it is as a formula for everyone who likes that one. And what you can then always do is kind of do a matrix of the probabilities, how these transitions, how likely these transitions are. And now this is pretty easy to kind of use for our problem where we look at transitions between URLs, right? So instead of the weather, we are considering different sessions and the URLs, how they occur in that session. And of course, we can just compute a probability matrix from this. So from every URL to every other URL, what's the likelihood for kind of each transition? And then the algorithm is actually super simple. So we just choose the row that corresponds to our current URL where we are currently on as a user. And then we get a vector with all the probabilities where we probably will go next. And now we only have to decide on the decision criteria. How do we want to decide what to preload? Should we preload just the top K most probable links, like the top 2? Or should we define a threshold, at least 5%, and then we preload? And then we don't care about how many we preload. The 5%, it can't be more than 20 at least, but yeah. So let's try that as well. Let's kind of train our model with 1 week of data, 2 million sessions, 9 million transitions. Just compute the probability matrix out of that. It's a really small 84,000 by 84,000 matrix. And then we can use kind of the next day after that week in order to see how does that help with our predictions for different kind of decision criteria. For top K, for example, top 1, top 2, top 3, we can see recall is going up from 16 to 27 to 33%. Precision, of course, if we preload more, is going down from 7 to 6 to 5. And also, I think we settle for the best F1 score even at top 1. You can also look at thresholds, some threshold T. We can do 1%, 2%, 3%. It goes the other way around, of course, with the recall and the precision. And we get a slightly better F1 score there at 3%. Now, this has already super many limitations. We are not considering any kind of history. We're not considering that maybe the day before our testing day would be the most influential and should be weighted more than the first day of the week, for example. And you can encode all of this into the Markov model. And I won't go into any detail on how that works because we don't have time for that. We also tried that, and you get marginally better F1 scores out of this. But this is not groundbreaking yet, right? So this is just kind of how do we get to a first approach? And we see really quickly that we haven't used a lot of the knowledge that we have yet. We have only used URLs and transitions between them. And there's so much more data that we can actually use in order to do that. So we can consider the device the user's on, the browser the user uses. Is it the first-time user? Is it a returning user? Is it a logged-in user? The page type we are on. A product page behaves differently to a category page. The traffic source, where does the user come from? But also, most importantly, information on the page. Which links are actually visible? Which links the mouse is close to? Which links are kind of in the field where you usually click on your device? Which links are large? Which links are small? Which links are maybe obfuscated? So a lot more information that should go in there, and a lot of different dimensions for which to evaluate all of these probabilities for. And this is where essentially the mathematical model completely falls apart, because if you want to compute these Markov chains for all combinations of dimensions, you can't do that. That just completely explodes. You have way too less data to do that. You have way too many models in the end. And yeah, this is essentially where you have to look for something like machine learning, because machine learning can get all of these dimensions and kind of figure out on its own which of them are meaningful and which not. And also they can then act on new data. So if the Markov chain receives a URL that it has never seen, there is no probability vector for that. We can't do anything. But the machine learning model, maybe it knows something about the user, about the link size, and about the page type. They can figure out where the user will probably click on. And to be honest, this is where we are currently at. We are looking into different models. We're trying out a lot of things, and we are doing a lot of things on the client that are really impactful. But still, we want to look at some really early kind of results that we saw in A/B tests with 100 millions of users. And in this approach, we used the hover preloads with a few optimizations on client side in order to not preload 1.8 million pages. And this already delivers quite some really interesting results and has us excited for better prediction models. So we can see here, for example, on time to first byte level, we have in gray the ones that were the group that didn't use preloads, and then the group that did use preloads. And we can more than half the time to first byte here, and even have about not quite 400 millisecond improvement on LCP. And this is exactly what we wanted to see. So even kind of really simple approach to prediction combined with the actually ability to preload a lot of stuff can lead to kind of really cool performance improvements already. And this is not even pre-rendering. This is only preloading the HTML, not even the resources, only the HTML file, because time to first byte in e-commerce is the biggest performance factor today. So really exciting. You can also not only see this in kind of the medians that we show there, but also in the complete histogram, so the distribution of load time. This is for the time to first byte for everyone sitting at the back. You can also come to the front to see better. There are still spots left. You can see that the red curve is without preloads and the blue with preloads, and you can actually see the distribution shift to the upper left. And people who were already pretty fast are extraordinarily fast now, and also people that were mediocre are much better. We also tried this for a page that is already super fast and using SpeedKit, of course. And even for them, they had 165, even I have to go closer to read this, 165 milliseconds of time to first byte to start with our standard optimization. That is in the median. That is quite a good number. But we managed to get this down to 79 milliseconds in the median, and also get the same impact on LCP. Of course, not as huge as on the first example, but still for an already that fast page, this is super cool. Really excited for what will come with better prediction models and with all the things that we are currently trying out. So hopefully I can report back once we have even more results that we are able to share. So quick wrap up, 3 key takeaways, I would think. First of all, predictive preloads is a huge potential, especially if you try to move towards instant page loads, which we as a company actually have as our kind of long-term goal. Second of all, you probably, if you have a complex system in e-commerce or somewhere else, you will need HTML caching. Otherwise, this probably isn't feasible except for some really specific use cases. And third, there is lots of room for improvements, lots of room for research, for machine learning, and for just trying different approaches. And yeah, that is actually what research is, I would guess. So that's it. Super open for questions before I will give it up for Tobias for the next talk. Looking around for questions. Brian.
What is F1 or whatever that is?
Yeah, exactly. So I will repeat the question for the recording that is now actually running. So let me jump back there. So the F1 score, Brian asked about the F1 score, what that actually represents. And since you have 2 metrics, recall and precision, it's always easy to get one almost perfect. You can preload every URL there is, and then you have a perfect recall. You can preload no URL at all, like a lot of us are doing right now. And then we have at least perfect precision. That's also pretty cool. Yeah, it's 0 divided by 0, but let's count this as perfect precision. So you need some way in order to weigh these 2 metrics or balance them against each other. And a standard approach in machine learning is the F1 score. So it's this formula, but I think everyone has to kind of look at this and make up their mind what it actually means in terms of how to balance them. It's not just the average out of the 2. But I also think it doesn't it doesn't score one more than the other. I think we should draw the curve. I think Mirko knows actually how the curve looks. Okay. Sorry, Mirko, for exposing you here.
No worries.
More questions. I promise to not expose anyone. Yes.
Are users able to opt out from preloading? Is there a browser flag or something? Because
Yeah.
it sounds dangerous.
Yeah.
Fuck shit up.
Exactly. If someone implements this by themselves, like you could do on your own website, you can't opt out as a user. You can just not visit that website anymore if you find out. But if you're talking about something like pre-render, you can actually opt out. I think, I'm not even sure. I like do not track maybe disables it, but for sure data saver mode disables it. And there are like 100 different things that cause it to not be active, which are really hard to figure out. Yes.
There is I think it's working first, reduce data media query. I'm not sure how the browser support is, but
yeah,
couldn't you basically check that and then
yeah,
if the user doesn't prefer it, then
right,
or prefers it, then don't do that.
Yeah. So the question was, now I actually repeated, the prefer to reduce data meta tag if we could use that, and as a developer themselves check for that and then don't do the preload. Definitely. Also the data saver flag and everything that is exposed there. And I guess that like things like pre-render that is implemented by the Chrome team already looks for things like that. I'm not sure about this in particular, but they look for a lot of things, whether it makes sense to do this right now. Next one.
The techniques you listed in the first or second, whatever.
Yeah.
Right? Are they standard? And I saw that they are like from Chrome, but how are they supported in Firefox and Safari and stuff?
Right. A lot of them. So if we go from the bottom, speculation roads is Chrome only, and also not super production ready. They are looking for feedback on that, and in a lot of cases it doesn't work. We can talk after the talk a bit about it. We did an A/B test on our website with that, and yeah, it doesn't enable every time you think it does. And I think pre-renders probably also only Chrome, and prefetch I don't know, but things like preload, pre-connect, and such, they I think work on all the browsers. You can check, can I use otherwise? Yes.
Two questions about the speculation rules, because it doesn't say, so it's defining a different type, right? It's not type JavaScript.
Yeah.
What happens actually if JavaScript is disabled? Is it?
Oh, that I don't know. So this is not executed as a JavaScript. So yeah, that's why, for example, Firefox or Safari will just ignore this and don't do anything with it. That's handy. But I don't know what it does if you disable JavaScript. But then again, please don't disable JavaScript. not if you're talking about e-commerce. Yeah. You can't use the web anymore.
Sorry, I have one other question. The preloading. Do you have like a guideline about how many things it's okay to preload? Basically, right?
Yeah.
You know, like you can't preload 10 things or whatever.
Yeah. So the question is, how much should be preloaded, and is there a guide? I think the blog post, so these are all links, the underlined things, to blog posts, mostly by Google, and they explain it in really good detail. Also, yeah, such questions, what you should actually preload and what not. But in the end, there is no kind of definitive guide to what to do. It is a bit of try and error, and then you do web page test, and it looks better. And then you deploy it and probably doesn't look better because it's not always the same. Yeah, it's a bit of a try and error, but things like critical resources that are not right away visible and can be discovered by the preload scanner, those for sure. The same with lazy loaded images that are like large contentful paint image, for example. Then again, you shouldn't not have them in your HTML to begin with, but things happen, and sometimes you can't do something about it. There's a question.
I'm wondering, what are your thoughts on these different preloading techniques? Which of those would apply potentially for a single page application if you want to have a similar type of prediction for prefetching in place? Which of them could work?
Yeah. So since if you have a single page app that does soft navigation, so no actual browser navigations. So the question was, what should single page apps do? So what should they actually use? Because they don't have actual navigations, like browser navigations, but they have like soft navigation staying on the same page from a browser's perspective. I guess preload would work because it keeps stuff in the preload cache, but then it actually assumes that you will consume it in a few seconds. And when you do not, you will get all of these warning messages. And I'm not sure how prefetch behaves in this case, because there's this different cache with prefetch, whether it doesn't only work on navigations because it's also used for resources. So that one might also work. Yeah, good question. Implement a service worker and do it yourself. Don't implement a service worker just for that, please. Yeah. Implement SpeedKit maybe. Yeah. All right.